Today, things start getting a little bit more complicated when it comes to proving triangles are congruent because you're going to start having more choices. And that's where it starts getting interesting. Up to this point, we've known if we wanted to prove that two triangles are congruent, we had to use side angle side. It was the only choice we had. But now we're going to start throwing two more choices at you, and they're called side, 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 and hypotenuse leg. First one is called side, 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 and it's probably the easiest of all of them. If all three sides of one triangle are congruent to the corresponding sides in another triangle, no angles necessary, just sides, three sides to three sides, then the triangles must be congruent. Side, side, side is probably one of the most obvious choices because you're only working with sides. You're not working with angles at all. So it's one that is not too tough to work with, but it's also one that a lot of people sometimes overlook because it is so obvious. So we got to watch for that. This is a pretty typical side, side, side proof. And I'm not giving anything away by saying it's side, 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 because if you don't anticipate that at this point in the lecture, you aren't doing a very good job anticipating what's coming up in class. And that's part of being a good student, is kind of anticipating what's going to happen. So here we have information. KL is congruent to NL, KM is congruent to NM. That's already given to us. And of course, first reason in our proof is given. Now, two things we always look for when we're doing triangle proofs. Well, first, we always start out with what is given is in the written format. What is written as given. Can I conclude any congruence based on that? Well, heck yeah, I got two pairs of congruent parts already. Next, what is given in the picture? What is given in the picture is the next thing we look for. Once you've exhausted the givens up here, then I look to the picture and say, what is given in the picture? In the picture, we're looking for some very specific things. We're looking for vertical angles and shared sides. So if we have two lines intersecting to form vertical angles, that's something we're going to probably be interested in. Or if I have two triangles that are sharing a side, where one segment is a side in both triangles, like LM right here. That's something I'm going to be interested in. That's a reflexive situation. So when I see a shared side, my reason is going to be reflexive. And I simply name it. LM, and it is a segment, is congruent to LM. I don't like L so much as a letter a lot of times because it looks like angle M is congruent to angle M there. And I apologize if that looks that way. In fact, just to make it a little bit more clear, I'm going to reverse the name from LM to ML. Might still look like M angle, but this doesn't look like angle M. Not that LM was in any way wrong. Now, what do I have? I have three pairs of congruent sides. I don't need any congruent angles. So I'm done. Triangle KLM, congruent to triangle NLM. And my reason, side, side, side. Side, side, side is my congruence theorem that I'm using here. So side, 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 pretty straightforward, relies solely on sides, nothing on angles, all congruent sides, and we've got it done. Do I have correct congruence statements in these pictures? So a couple things I have to analyze as I'm answering yes or no to these types of questions. First off, do I have sufficient information for one of my shortcuts? So far, are side, 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 and side angle side. And second, is the statement in the correct corresponding order? So let's look. It says DFG and HJK. Well, first I look, and DFG and HJK, yes, I have side, side, side. So yes, I am okay. Is it in the correct order? Does D go with H? Yep. Does F go with J? Yep. And G goes with K? Yep. So that one, yes, we are good to go. And it's side, side, side. Second one, ACB to CAD. So ACB has sides of 3, 7, and 9. And CAD has sides of 9, 7, and 4. Oh, they are not congruent sides, are they? The 7 goes to the 7, that's fine. The 9 goes by itself, but the 3 and 4 don't match, so not congruent. Corresponding parts are not congruent. Here, QPT and RST. Okay? QP goes with RS. Yep. PT goes with ST. Yep, they're congruent. And finally, QT goes with RT. Yep, indeed. Yes. We're good. We're in the right order. And again, side, side, side. Sorry, I don't know what I was writing there, but I'll try again. Here we are. Side, side, side congruence. It's not too tough to recognize when we see it. It's one of the easier ones to work with. Hypotenuse leg is a little bit more difficult. It's really not bad. It's two sides at an angle, kind of like side angle side, except the angle is no longer between the sides. And in fact, the very name of it, hypotenuse leg. Does every triangle have a hypotenuse? Is a hypotenuse simply the longest side of any triangle? Or is a hypotenuse special? What is a hypotenuse? The hypotenuse is the longest side in a right triangle. Only a right triangle has a hypotenuse. So this requires both my triangles to be right triangles. Once that's true, once we know they're right triangles, this comes into play. This is a special theorem. It only works with right triangles. It's not the only thing we can use with right triangles. I could use side, 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 or side, angle, side with right triangles. In fact, we have used side, angle, side that way. But this is special for right triangles. Notice what's congruent. We have the hypotenuse is congruent, and we have one leg congruent, one corresponding leg. Because remember, the parts of a right triangle, we really haven't talked about this yet. We have a right triangle. This is a leg. This is a leg. And this is the hypotenuse. So it's saying hypotenuse leg. It's saying a hypotenuse and one of the legs is congruent to the hypotenuse and one of the legs in the other triangle. That's enough to prove that the triangles are congruent. But in order to do this, we have to have right triangles. As I said, this one is more complicated. So if we're going to do a proof with hypotenuse leg, it's going to require somewhere in that proof for us to state that I have right angles, and that makes the triangles right triangles. So let's see what we start with here. We start with WY congruent to XC. All right, let's note that. WY, ooh, that's not going to be easy to do, is it? Because these triangles overlap. What kind of strategy could I employ in a circumstance like this, when the triangles overlap? Well, I could separate them. W, Y, Z, and Z, Y, X. So I could kind of pull them apart just so it's easier to see what's going on. And then mark them up. WY is congruent to XC. That's given. We're also given that these two lines are perpendicular and that these two are perpendicular. So I can mark that in my drawing. Much easier to see in the lower picture. So when you have overlapping triangles like that, sometimes it's easier to pull them apart. That's given. Well, what do we have? We have perpendicular lines. Perpendicular lines, what are we given? We start with our givens, and then we use our givens to try to prove that parts are congruent or something else is going on. Well, perpendicular lines give us right angles. So that means, since those are perpendicular, that angle Z and angle Y, or in this case, angle WZY, and angle XYZ are right angles. Why? Because the lines are perpendicular. Because definition of perpendicular lines. By the way, don't ever talk about perpendicular angles. There's no such thing as a perpendicular angle. There are perpendicular lines. There's no such thing as a perpendicular angle. Next, since those are right angles, that means that triangle WZY and triangle XYZ are right triangles. This is the hard part right here of hypotenuse leg, is we always have to have these statements. By the way, that's the definition of a right triangle. Okay? I can't do hypotenuse leg unless I have those steps in my proof. I have to have those steps. Once I've established the right triangles, I have the hypotenuses congruent. We have that. That's the hypotenuse and the hypotenuse. Now I need one pair of corresponding legs congruent. My legs are WZ and XY. I don't know anything about WZ and XY. My other ones are ZY and ZY. Oh, ZY. Oh, that's a shared side, isn't it? ZY is congruent to YZ. Now, I could say ZY congruent to ZY, YZ congruent to YZ. I can say that in any order. But what's the reason something's congruent to itself? You're right, reflexive. And then finally, triangle WYZ is congruent to triangle XZY by HL. So HL proofs are more difficult because we always have to have those statements in red there. Statement that we have right angles, and then the statement that from right angles, the right angles give us right triangles. I can't do hypotenuse leg without those steps. It's kind of picky. More often we're just asked to use it, not actually do a full proof of hypotenuse leg. And again, that just gets us to recognize what's going on here. So do I have hypotenuse leg in this situation? Well, I got my right angles. So I got my right triangles. I've got my congruent hypotenuse, that's given. What else do I need? I need a corresponding leg congruent, and I do indeed have a shared side. And then I can go ahead and do that. The method that they're suggesting here is to redraw this picture. So both triangles, but are separated, but not just separated, but also oriented the same way. So that requires a technique that some people struggle with a bit, so I don't spend a lot of time on it, but it means pulling it out and like flipping it. So this angle A is over here now, this angle B is down here, and this angle C is up here. Now I can see more accurately what's going on, but it's a little tricky to notice that this BC and this BC are the same because the letters are flipped around. But if you do notice it, it's a pretty quick way to see hypotenuse leg. So, like we said, hypotenuse leg, a little more complicated, side, fairly straightforward. We're spending plenty of time here, and we'll have plenty of time to talk about it in class as well. So we'll see you when you get to class.